we see something more advanced. We will also see how we can use DAX Studio to read data that we can generate from Power BI Performance Analyzer. My name is Marco Russo. I'm part of Sigur BI. We produce content for DAX and data modeling, Power BI analysis services. You can find everything on our website. I have only one slide, this one. So I will spend more time in demos. Power BI Performance Analyzer is a feature within Power BI Desktop. You can only use it in Power BI Desktop, not on a service. And the idea is to retrieve information from the page that you are executing with a report, information about the time required to execute each visual, and the time required to execute each part of the pipeline required to generate the visual. When you create a page, a report page in Power BI, and for example, I have this page in Power BI, don't look at the quality of the report, also because I had to adapt it to the resolution to make it bigger when we look at some detail. But the idea is that every single visual of this report is an element that is isolated from the rest. So the element doesn't know anything about DAX. What does it mean? When you have a visual and you provide information like the measure that you want to display, the attributes that you want to display, the visual defines a semantic query. So the visual says, I would like to see this measure sliced by this column and filtered by this other column. This information is not DAX. It's what is called a semantic query that is sent to a service that is still in Power BI Desktop, but in case of the service is on the service, that generates the DAX code. So when you create a visual in Power BI, in case you want to create a custom visual, you don't have to generate DAX. DAX is always generated by the data shape engine in Power BI. So this stage requires time, and also executing the DAX query requires time. So the visual says, I want this data, this request is converted into DAX, the DAX code is sent to another service, analysis services. When you have a live connection, this service is remote on Power BI service or on analysis services. When you use Power BI Desktop importing data, you are using analysis services running on your machine, but it is a different process. This request takes time. We call this the query execution time. When the data is retrieved from the DAX query request, the result is just a table. You see a map, you see a line chart, you see a matrix, doesn't matter. The visual receives one or more tables with data, and this data is rendered, is displayed in some graphical way. It depends on the visual that you chose. But besides the visualization, the pipeline of the execution is always the same. Power BI Performance Analyzer can provide us insights about what is happening, especially the time required to execute each step. Why do we need this? In order to understand why a report is slow and to narrow down the problem to a single visual and maybe then to a single part of the visual. Is it the DAX query slow or is it the rendering slow? If I provide to the visual 10,000 data points, the visual will require more time to display 10,000 data points compared to a visual that receives only 100 data points. And we can see all this information with a Power BI Performance Analyzer. So let's go to the demo. I have a report. This report has many visuals, and the user says this report is slow. You can go in the View tab here, and let me open this bigger. So in the ribbon, in the View section of the ribbon, you have this button, Performance Analyzer. When you open Performance Analyzer, we have this pane where you can say, I want to start the recording, which means that from now on, every action that you do over the page will generate events that will be collected in this pane. So for example, if I click on a bar chart, now this is not visible, but you see whenever I click something, there are a number of operations happening. So the click generates a cross-highlighting event that is displayed here. Now, when you have a slow report, usually you just want to see which of these visuals is the lowest one. So one thing that you can do, you can clearly clear this list, and then you can say, I want to refresh all the visuals. When you click this button, refresh visuals, you see that every visual is refreshed. Now, you don't see this happening because I'm just refreshing the visual over the same data, but you can see on the right that every visual had an execution time. So first of all, how do we identify the visuals? Sometimes you have a name. The name is derived from the title that you can provide to the visual, but sometimes the visual has always the same name. A text box is, for example, this element. And you see that when I click on one line here, I highlight the visual that corresponds to that element, to that visual. Sometimes you have to do that because the name doesn't tell you much. Now, I'm clicking on a text box. A text box doesn't have any data. Indeed, you see that when I drill down, so let me close this. When I drill down the time of the text box, I see that the time required to render, to display the content of the text box is 150 milliseconds. The time that you see, the duration, is always in milliseconds. And this time is divided in two different elements in this case. The time to display the data, other. What is other? We'll go in a minute, but other means some other time, something that does not depend on the visual itself. Basically, other means I'm waiting for something else. We will go back on this concept in a moment. Now, if you look at this report, you see that there are numbers here. We have one visual. You see that whenever I move the mouse, I highlight a different visual. And you can see that when I click here, a different visual is highlighted too. Now, each visual retrieves data from the model. And actually, we have a measure and we have a few filters for each visual. These are cards. We have a lot of cards in a page. Now, if you look at this card, you see that, oh, we had 1 second, 1,000 milliseconds, 1 second to display just one visual, one card visual. It's a lot of time. But if we take a look at the time required to display this visual, we see that we actually spent 16 milliseconds to retrieve the data. So the visual sent the request. The request has been converted into a DAX query. The DAX query has been sent to another process. The process received the query, executed the query, created the result, sent the result back, just a number, and the visual received this result 16 milliseconds. The visual, to draw that number, spent 36 milliseconds, actually double the time to do the hard job in DAX. So DAX is fast, right? But we spent 982 milliseconds waiting for something else. What? Well, I think that the problem is the following. Let me see if I can do this. Can I do this here? Oh, wait a minute. I can do this here. I need an empty. Come on, this way. I wanted to do a white screen. So let's say that this is the time. And at this point in time, we open the page. We have, in that visual, around 60 visuals. Now, if all the visuals started the rendering at the same time, we could assume that if each visual requires 30 milliseconds, after 30 milliseconds, everything is ready. I don't know you, I'm able to do maybe one, sometimes two things at a time. Women are much better than me, and they do 5, 6 things at the same time. But Power BI is not that good, and it does maybe 4 or 5 things at a time. So the reality is different. The reality is, and let me repeat this. If this is the time, and this is the starting point, and assuming that we have from 1 to 60 visuals, you have 1, 2, 3, 4 visuals that are rendered at the same time, then the other visuals had to wait. And at this point, the other visuals start, but you can imagine that this is what is happening for real. So this is the total execution time. And when I look at this visual, this part of the time, other. I'm waiting for other visuals to complete the visualization. If you have a report like that, your only way to improve the performance is to reduce the number of visuals you have in the same page. How can I do that? Be creative. There are several techniques. In this particular case, we have cards. Each card is a different visual. Luckily, we have another visualization, a custom visual called card with states, where a single visualization can include different cards. Why is this faster? Let's take a look at what happens when I open the performance analyzer. When I start the recording and I refresh all the visuals, you can see that the time required to display the entire content is shorter. If we take a look at a particular visual, you see that the time required to retrieve the DAX result, not just for one number, but for maybe 10, 20 numbers, is still small, 6 seconds, but the visual display is much more. Instead of spending 30 milliseconds, we spend 300 milliseconds to complete the rendering of the many cards. So not that better, but because we reduce the number of visuals, we reduce the number of queries, we reduce the overhead of this communication between different processes, and overall, other is smaller because we have a smaller number of visuals that had to be put in a queue and displayed. Okay? Please remember that also these visuals, a simple text box, count as an element. So another technique that sometimes people use is to create a graphical background with all the lines and all the decorations so that they avoid having a lot of small visuals just to display a border or something like that. Okay, this is another approach you might have. Now, we want to focus, however, on the performance analyzer. What can we do here? Well, we have the ability to sort the visuals in an ascending order, in a descending order, depending on what? Depending on the action order, simply the position of the visual in the report, or by total time. And usually what we do, we do this. But when we do this, we are displaying the first visual is the slowest one in this page. But is it really true? If we use the total time, it is not true because we simply see which one is the visual that waited more. Probably the visual that was the last in the list of the visuals to display. So if we want to understand which visual is slower for the visual display, for the rendering time, this could be important when you have a map with thousands of data points. You will probably see that the map is not that fast. You could use this criteria in order to choose the sort order. Or if you want to find the slowest visual for the DAX code, because you want to optimize the DAX code, then use the sort by DAX query time, this one, DAX query. And this way, you see that the matrix that we didn't even open is actually wow, 9 milliseconds is still fast, but it's the slowest visual. So actually, if this is the slowest vision in the report, we know that DAX is not a problem in this report. But the goal here is to get an idea about what Performance Analyzer can do for me. Now, Performance Analyzer in reality collects many more information than what we have seen so far. How can I see this information? You can export the result of this analysis, of this data collection, into a JSON file. So when I click export, you see that I have the ability to save this JSON file on my computer. So I save this file. And now that this file is available on my computer, I could go in the demo folder, and I can open this file, for example, with Visual Studio Code. Now, this is just to show you that what I have is a JSON file. But to be honest, this is just to get an idea. How can you actually manipulate this JSON file? Let me see if I remember the format for this. No. Control Shift F, Alt Shift F, Alt. No, don't remember. Okay, but this is a JSON file. I don't remember the shortcut to display this in a structured way. So this is the format that we have. Luckily, we can see this information using DAX Studio. DAX Studio is a tool, an open source tool that you can download, install. It's free. And one of the features that DAX Studio has is the ability to import this file. So I can go here, I can click this button, load performance data, and when I click this button, I can choose the JSON file I exported from Power BI Performance Analyzer, and what I get is this list. This is the list of the events in the Performance Analyzer output that include DAX code, because the DAX Studio goal is to analyze also the DAX execution. And an important element here is that we have an information that we actually don't have when we look at the Performance Analyzer pane, which is the sum of the time to retrieve the DAX result and the time to display. So the display time and the DAX query time summed together are this number. We ignore the other number because the other number is confusing. It doesn't tell me much. I just know that, okay, I know that there are too many visuals, but I don't understand which visual is actually slow. So if you want to sort this list by total milliseconds, you can see that overall, the slowest visual is this one. This information is impossible to obtain when you use a performance analyzer because you don't have a sort by the sum of these two columns ignoring the others. This is just an example. And of course, if you double-click a line, you can see, copied in the DAX editor, a few other details and also the number of rows that have been retrieved by the visual. This is another information that we have in Performance Analyzer, how many rows have been collected, how many data points the visual received, but they are not displayed by Performance Analyzer in Power BI Desktop. But the information is available and is here, and is also displayed, as you can see, here in this column. Query millisecond is the DAX query time, render milliseconds is the display time. If you are interested into the details of the JSON format that is exported by Performance Analyzer, Microsoft has a documentation, or better, has a GitHub repository with a document that is a Word document that has a number of details about the content of this file. So, I don't know, it's not official documentation in the Microsoft website, but it's actually a good content that can help you finding other ways to display this data if you are interested to. Remember, provide feedback about this session. This is the QR code. You can also see the short URL to do that. Thank you for attending. If you have any question, please raise your hand, and otherwise, come here. Question there, quickly? I cannot hear.
How does it apply for some of the external services like cognitive service integration and Azure Machine Learning Service? Can you still do that same kind of analysis?
Okay, so the question is, do we have some integration with other Azure services or Power BI services? Absolutely no. Performance Analyzer only works in Power BI Desktop, only works with the model that you have locally. Now, if you have a live connection, it still provides you some information, but it works better if you have composite model. But everything happens remotely, you cannot see it. You can only see what happens in your local analysis services. Question?
Question online. I have built a page using the new bookmark navigator.
Okay.
And it has really slowed down the report. Now that I have lots of visuals on one page, I used to have them on different pages and use normal bookmarks and navigated to the other page. How could this be optimized while still using bookmark navigator?
Okay, so the question is very specific about a problem about the performance caused by the presence of a bookmark and the navigation in a bookmark. What Performance Analyzer can do is providing you information about the visuals that are in one page. If the problem is caused by the presence of many visuals that are hidden and only there for the synchronization with other pages, you might find it. If it is something else, maybe we cannot find it. I cannot be more helpful in this case, sorry. Other questions? Yep. It's impossible, like.
Is there a way to relate that to your query plan of your DAX?
Okay. The question is, can we relate to the query plan? Actually, the query plan is not something that Performance Analyzer is aware of. What you can do, if you open this file in DAX Studio, and DAX Studio has been opened as an external tool over the same Power BI desktop file, you can just run this query and capture the query plan. But the query plan has to be obtained by another execution of the same code. You cannot retrieve the original execution plan that happened when you ran Performance Analyzer because this information is not collected. Last question, then we have to leave. One more question? One more, two more, no? One more, last one, okay. Yep. We want to go to the previous page, sorry?
Yeah, you had it on a page 4 that we had the GitHub link.
The GitHub link, okay, yes. For okay, yes, I understood. If you download the slides, you will find a link there. The slides will be available. The question was, what is this link? Is because it's a long URL. It was on GitHub, but if you look for Performance Analyzer export file format on GitHub, you should land on this page, which contains exactly this document. Otherwise, send me an email or just wait for the slide to be available. Okay. If you have a question, you can join us here. We have to leave for the next session. Thank you very much for attending. Remember, provide a feedback.